So this first part, we are gonna organize the data in matrix in Matlab. So let me just start by sharing my screen. And here we have Matlab, right, open, so it's not file here. I'm gonna just clean my command window. So we are gonna import all of the data in Matlab in a kind of in a structural variable, organized variable. So I'm gonna start by this variable that I already created for previous test. It's called tension anneal niobium, which was the previous tensile test that we performed. I'm just gonna take this one, I'm gonna duplicate and rename. Probably I'm gonna just call it batch annealing tensile, batch annealing samples. Okay. So as you see here, if I double click, basically contains the same information from the other data. So this is the niobium, this one is the batch annealing that we created. And this is all data, so I'm just gonna select this. It's kind of like a spreadsheet. So I can select the rows, right click and delete rows. So I just stay with 2 rows for now. And as you see here, basically this is a structural variable which contains different kind of data. In the first column, it just contains text. When you are putting text in this kind of structural variable, you need to use the apostrophe, because in other ways, it's not gonna recognize the text. But the regular data can be just typed directly. In this case, regular data for width and thickness of the sample. In this case, each row represents one sample. So this is sample number 1 with thickness. Strain rate is constant for all of them, so we don't worry about that. Data is the data that we imported or imported from the MTS frame, for the tensile frame. And these other rows are just basically calculations that I do when I'm running the tensile analysis. So basically we can calculate the yield stress, maximum strength, elongation, and some power law relationship. So this is gonna be calculated later, so we don't need to worry about these values, but we are gonna create another columns because we have extra data, especially for the second extensometer and also the final width and thickness. So we'll be doing that in a minute. But let's start creating a new row. So basically, let's see what files do we have. So basically, if we see let me see what we have. So the data that we have from the tensile test comes all of these data files, right? So initially we have this specimen, which is 550 1L, I guess longitudinal for 1 hour. And this is the experimental data. So I'm just gonna take the text file, the dat file, and copy and paste here in my Matlab folder. I already have this, but I'm just gonna duplicate or, overwrite this specimen.dat. And I'm gonna create here name. So in this case, this is for the test. Let me just double click here, Control C. I'm coming to Matlab. I'm just gonna double click here, apostrophe, Control B, apostrophe. So that's the name that I'm gonna give. And as you see, basically I created a new row. This other 2, I'm gonna delete it later. I'm just gonna use it as a reference. Width and thickness, we also have a file for width and thickness. So this is the data that you send me, the measurements that we did. So we have for 550, 1 longitudinal 1 hour. This is the width and thickness. So I can directly copy from Excel. Obviously the same kind of orientation. So in this case, width first and thickness after that. So Control V, we have width and thickness. The strain rate again is the same for all of them, 1 to the power of -3. So we don't worry about that. Now we need to put the data of the tensometer here in this row. So as you see, basically this is a cell which contains more data. So if you double click, enters to a different variable, basically contains all of the experimental data from the in this case the extensometer. So I need to save all of this data here, but first we need to import it to Matlab. So basically we have this specimen data copy here file. I'm gonna use this program called import file, double click. So this is a function. So basically I'm gonna copy this function in the command window. So basically it's creating a variable called a specimen, call this function, and I'm gonna place here the name of the file that I wanna import. In this case I can just also rename here, Control C, and place it here. But always use apostrophes for files and names. So in this case, in between apostrophes, specimen, and dot, that, the extension of the file. The starting row is the initial row that we are gonna process. So for example, let me just open here externally this file and the text file. So you see there is some rows that are covered by text or by other things that we don't want to cover. So in this case, we have 1, 2, 3, 4, 5. The 6th column is the one that I'm actually gonna start to process. So I need to select like the start row, at least the 6th one. If I start by earlier, it's gonna generate an error because it's gonna be text, and I'm just trying to import data. And the end row doesn't matter. I just leave it like without anything. So when I process this, basically it's creating a new variable called specimen, as you see here, because with this name. And this specimen contains all of the data. If I open again manually outside Matlab, basically you see the data started in this. Basically, I didn't consider the first one. I mean, I can just reduce this number by 5, so starting here, but it doesn't matter. So I'm starting here in this case. That's okay. So we have a specimen as a matrix, numerical matrix. So basically, I'm gonna try to save this matrix in this cell. And for doing that, basically, Matlab is really straightforward as another codes. So basically, first you need to put the name of the variable, in this case, tension, batch annealing samples. In parentheses, we are gonna put the column, the row that we are gonna save. So in this case, row 3, right? And dot is the name of the column. So in this case, dot data, which is the name of this row, data, okay? And it's gonna be equals to, in this case, equals to specimen, which is the variable that we wanna save. And I can use the semicolon to just show that in the command window. Enter. So basically, as you see, this variable was saved in this particular cell. So that's what I wanted, right? Now, I said I'm gonna create a new column for the second data, for the second extensometer. So what I do easily, I can just select this row, right click, just create a new one here, new cell. I'm gonna delete everything. And as you see here, this is on name. I can double click here and I can change the name to data 2, for example. That's gonna be the data for the second extensometer. So I need to come to the data and see what is the data for the second extensometer. In this case, this is the data for the second extensometer with the same. Make sure that you always obviously use the same, files, same reference. So I'm gonna copy this and I'm gonna paste in my work current folder. And I'm gonna use now an import file 2, which is using a different function to import the second file. So in this case, I'm gonna copy this to the command window. So it's gonna create a variable called specimen2, calling this function. And now I'm gonna use rename. I'm gonna use this file name, but between apostrophes, and in this case is that .lvm. Okay. Now the number of data lines, again, if I open outside Matlab, basically this has more text columns. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 15, 14, 15, 16, 17. 21, 22, 23, 24. So basically, we need to skip 24 lines. So I'm just going to use as a data lines 24. Okay. Enter. And basically, I created a variable called specimen2, which contains all of that experimental data here in Matlab. So now, again, I want to save this specimen2 in this data2. So I use the same way that I did before. So now I'm gonna say tension, batch annealing samples, which is the name of the file, parentheses number 3, which is the row, dot, in this case, the name of the column, which is data 2 in this case, okay, data 2. So if I say data, it's gonna override this one. Obviously, we don't want that. We want to put it here. Equals to specimen 2 and semicolon there, enter. So basically this data is gonna save here. That's it. Now let's create two new columns here. I'm gonna delete them, the data, and this unnamed one is gonna be width final. I'm gonna call WF, and this unnamed, the other unnamed is gonna be thickness final, so TF, thickness final. And what I'm gonna do is I'm gonna bring the data from the Excel file that we have and just copy this too. So now we created this new variable. And the idea is to do the same for all of the other columns. So we need to have all of the data. So that's the first step. When we have all of this data organized, we can go ahead and use the other code that I have for calculating the stress strain curves. But that's gonna be in the next step.